car manufacturers have developed a variable cam timing system that adjusts the cam to crankshaft timing depending on change in the engine speed and load. The engine computer plays a vital role in the engine's performance, as it adjusts the camshaft timing depending on the vehicle's engine speed and load. In any range of engine speeds, only one camshaft position in relationship to the crankshaft is optimum for power and economy. Pressurized oil is controlled by the engine computer through an oil control solenoid, which allows engine oil to flow to the cam timing actuator or phaser. As the oil is forced into the actuator, the camshaft timing advances. When the pressure is released, the return spring returns the actuator to standard position, or the actuator is returned by using oil pressure itself, depending on the system. There are three basic variable valve timing systems. One uses a return spring to set the cam sprocket back into its resting position. This system is more primitive and older in nature. The second system uses oil pressure itself to control the position of the cam. This system is now widely used with some variations. It employs a duty cycle controlled solenoid to set the cam sprocket in the desired position. By controlling the duty cycle exactly, the cam sprocket and oil valve is designed to move forward, lock, and backwards depending on duty cycle. In a sense, all the ECM has to do is control the duty cycle in combination with the cam position sensor. The third system is a fully electrical variable cam timing, which uses a brushless electric motor to control cam timing. This system is now adopted on Lexus vehicles. In this video we can see the second, before mentioned, cam timing control system using oil pressure alone. Here's how it works. Variable cam phaser or VCP replaces the standard pulley, sprocket, or gear in a gasoline engine's valve train. It enables the cam lobe timing to crankshaft timing to be changed while the engine is operating, based on the parameters of the engine. This variable cam phasing system includes an oil control solenoid, which controls the flow of oil to advance and retard the camshaft position. The cam angular position, or phase relationship, is controlled by the internal vane mechanism of the sprocket. Commands from the engine control module adjust the position of the oil control valve, which is mounted in the cylinder head, and regulates engine oil flow to either side of the vanes. The oil flow and direction regulation is achieved by modulating the duty cycle to the VCT solenoid. At under 50% duty cycle, the oil flows in one direction, retarding valve timing. At 50% duty cycle, the cam is locked in place. And at over 50% duty cycle, the cam timing is advanced. Both sides of the control curve, retard and advance, are infinitely variable. Variable cam phasing changes the timing of the valve lift event. It can be used to shift the intake cam or the exhaust cam. This increases engine efficiency, improving idle stability while delivering more torque and horsepower. It also helps boost fuel economy and reduces hydrocarbon emissions. This variable cam phasing technology achieves a balance of response times and torque capacity. The construction of the cam phaser and the oil control valve permits continuously variable control of the intake and exhaust cams.